Hello everyone, my name is Karan Mashru. Welcome to this video. So in this video, we are going to look at the solution of the problem, that is wildcard string matching. First of all, let us start by understanding the question. What does question say? Given two strings wild and pattern, determine if the given two strings can be matched given that wild string may contain star and question mark, but string pattern will not contain star and question mark. But it will not contain. Star and question mark can be converted to another character according to the following rules. So basically we are given two strings wild and pattern, and we need to tell whether we can match them or not. Okay, and in pattern there are no special characters, there are only English characters, and in wild there are English characters as well as star and question mark. But this star and question mark can be converted to English character. Now how the rules are given here? Star, this character in string wild can be replaced by any sequence of character. It can also be replaced by an empty string. So if there is a star, we can replace it by anything. Okay, so we can replace it by empty string or one character string or two character string or three character string or anything. Okay, question mark, this character in string wild can be replaced by any one character. So question mark can be replaced by exactly one character. It cannot be empty, it cannot contain two characters or more. It should be replaced by exactly one character. For example, if my wild is this and pattern is geeks, so can I convert this into this? Yes. How? I can replace a star with E and it will give me geeks. Okay. Example 2, can I convert this into geeks for geeks? Yes. How? The question mark can be converted to exactly one character, so I will convert it to E, and the star can be converted to any sequence, so I will convert it to 4 geeks. So this will be replaced, the star question mark will be replaced with E and star will be replaced with 4 geeks, and hence we will get geeks for geeks. You don't need to read input or print anything. Your task is to complete the function match, which takes the string wild and pattern as input parameters and returns true if the string wild can be made equal to the string pattern, otherwise returns false. The expected time complexity is length of wild string into length of pattern string. Expected auxiliary space is also length of wild string into length of pattern string, and the constraints are given here. So now if we think about solving this problem, so basically we are given two strings wild and pattern, where this pattern contains, let's say, English alphabets. Okay, a smaller case English alphabets. The wild contains a smaller case English alphabets, plus it also contains star, plus it also contains question mark. Now here the star in the wild can be converted to any sequence of characters. Okay, it can be empty, it can be one character, it can be two character, or so on. And the question mark can be converted to exactly one character. Okay, it cannot be empty and it cannot be having more than one character. So exactly one character. Okay, so we need to tell, can we match them? So can we convert wild into pattern? Yes or no? So what can be the brute force method? So the brute force method for this will be to just recursively do all the possible combinations. So for example, what I will do is I will call a function which will have n and m. Okay, let me say n is the length of the wild string and m is the length of the pattern string. Okay, so now there can be there can be multiple cases. First is, this is the wild string, this is the pattern string. Let's say the n-1th character and m-1th character of both them are same. Okay, so I will say that function of n-1 and m-1 should match. So what basically this recursion function is, I will call the recursion function nm, and this will return me true if the n size prefix of wild string can be matched with m size prefix of the pattern string. Now n size prefix and m size prefix means complete string, right? So this is true. Let's say if wild of n-1 is same as pattern of m-1, because nth and mth character will be at n-1 and m-1 index. So this function shall return me true if this is true and if this function returns true. So the last character matches, as well as the first n-1 length prefix of wild string can generate the first m-1 length prefix of the pattern string. This is when both of them are same. The other case would be when the pattern of m-1 is question mark. Okay, so if it is question mark, I can place the character which is at n-1th character in the wild, this is the pattern string, right? So I can say another case would be when the n-1th character of the wild string, n-1th character of the wild string is a question mark. If it is a question mark, I can replace it with the exact same character which is at m minus 1th position of the pattern string. So I'll again get the matching of the last character. So this should return me true if this is a question mark and my function n minus 1 comma m minus 1 also returns true, because only one character has matched. The remaining pattern should be generated by the remaining string, right? The remaining wildcard string. Or the third case would be if the wildcard character at the if the wild string at the n minus 1th character has a star. If it has a star, it can be empty, it can contain one character, it can contain two character, and so on. So if it is empty, then in that case, if I get f of n minus 1 or n minus 1 comma m or f of n comma m minus 1 as true, then in both the cases this will be true. How? If the last character is a wildcard character, then what I can basically do is the remaining string of the wildcard character, if the remaining string of the wild string, that is n minus 1 characters, can generate the m length string of the pattern, then I can keep this star as empty. So if this is true, or if the remaining string can be generated using all the complete characters. Why I am not taking here n minus 1? Because this star can contain more than one characters, right? So I matched this star, I took one character which was at m minus 1th index, and so the length became m minus 1, but this will still remain n only, right? Because this is not a question mark or a character that I decrease the length of this. This is star, so I can keep the length as n only, because I can use this star again also for m minus 1th character, right? And the last case could be if the wildcard character is not question mark, if it is not star, if it is not matching, then in that case we will simply say that this is false, right? Because if those two are not matching, we cannot go further, right? So this is the complete thing, because if there is a character in the wildcard string, it is not question mark, it is not star, and there is a character in pattern also, and if they are not matching, then how can we go further? Now this is the first thing. Now this will further have 4 calls, which will be equal to f of n minus 2 m minus 2 in case this character matches, like how this matched. Then the other call would be f of n minus 2 m minus 2 again in case there is a question mark. The other call from here would be f of n minus 2 comma m minus 1, or f of n minus 1 comma m minus 2 in case there is a star at n minus 1th position for the wild string, and the fourth case would be false. Okay, and so on. There will be 4 calls for different things, 4 different possibilities at all recursive calls. When we will stop, if at the end, what will be the base case when I will stop? When either of the string length becomes 0. If both of them becomes 0, we will return true, because a pattern 0 with the help of wildcard string 0 length can be made, because both of them are 0. If the wildcard string is 0 but the pattern is not 0, then we will return false, because from 0 length string we cannot generate a string which is of greater length. If this pattern is, let's say, of p length, where p is greater than 0 but our pattern is 0, then in that case our pth character here should be star. So basically we should have all the stars, right? Basically I can say this will be f of p minus 1 comma 0, and wildcard of p minus 1 must be equal to star. So what this trying to say is, can I generate a 0 length pattern from a p length wildcard? Yes, you can. If you can generate a 0 length pattern from the remaining p minus 1 characters of the wildcard, and the pth character of the wildcard must be star, so that you can replace the star with the empty string. Let's say your wildcard string is star 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 and your pattern is empty. So you can replace this with empty, this with empty, and this with empty. So when any of them becomes 0, or when both of them become 0, depending upon the condition, we will return true or false. And when the recursion tree will return the results, this function will return me true or false. That is, whether can I, using the prefix of length n of wildcard string, can I generate the prefix of length m of pattern, that is nothing but the complete string. Now let's look at its actual implementation for better understanding, and then we'll discuss the time and space complexity. But so now this is the recursion solution which will give me whether I can generate the pattern from the wildcard string or not. But this will take exponential time because this is recursion. So I need to think of something more efficient. Can I think of dynamic programming because I want to convert the exponential time limit into polynomial time limit? Yes, I can do that if there are overlapping sub problems. Means the same problem is solved again and again by the recursion. Do I see it here? Yes. How? See, this is f of n minus 2 m minus 2. This is f of n minus 2 m minus 2. From here also further there will be f of n minus 2 m minus 2. Then here there is f of n minus 1 m minus 1. Here there is n minus 1 m minus 1. Right, and so on, and further also you will get a lot of repetitions. So now we can solve this using dynamic programming. What will be the state of dynamic programming? I need to take a 2D array dp of n plus 1 and m plus 1, where dp of ij will denote whether I generate the j length prefix of pattern using the I length prefix of my wildcard string. Okay, so this will denote this. And finally we will return dp of nm, where this will denote can I generate m length string of pattern using the n length string of my wildcard string. Now let's look at its actual implementation. So if I look at the actual implementation, so I have taken m as the pattern size and n as the wild string size and some variables ij. I have declared a table dp of n plus 1 m plus 1. First of all, I have defined the base case because I am doing it in bottom up manner. So dp of I am trying to fill this table. So dp of 0 0 is true. This is the base case which we saw. If both of them are empty, we can write true. Here, if the pattern to be generated is of length greater than 0 and if the wildcard string length is 0, then I definitely cannot generate that pattern, right? So dp of 0 comma I, where I ranges from 1 to m, is false. Then if the wildcard string is greater than 0, that is the wildcard string length varies from 1 to n, in that case if the wildcard character at the ith position is star, then dp of I 0 is equals to dp of I minus 1 0. Basically, you can generate a 0 length pattern from the I length wildcard string if the character at the ith position, that is I minus 1th index, is a star, so you can replace it with empty subsequence, and you can generate a 0 length pattern using the first I minus 1 characters. Okay, so obviously we have filled this, so before this, so using this we will get here true or false. If it is not a wildcard character, if it is a question mark or some other character, then definitely using a wild string of length greater than 0, and we cannot generate a 0 length pattern, so we will write false. And then here for I equals to 1 to n and j equals to 1 to m, if see now what is happening, we are basically mentioning this different conditions, okay, which we mentioned in recursion. So if the pattern at the j minus 1th position and I minus 1th position matches, then dp of ij is true if dp of I minus 1 j minus 1 is true. So what basically is saying, you can generate j length pattern using the I length wildcard string if the jth and the ith character are same, and you can generate j minus 1 length pattern using the I minus 1 length wild string. Okay, else if the wild string has at the I minus 1th position a question mark, you can definitely replace it with anything. So again dp of ij is equals to dp of I minus 1 j minus 1. Why? Because the ith character in wildcard string is a question mark, so you can replace it with the jth character in the pattern, and the remaining j minus 1 characters of the pattern must be generated from the I minus 1 characters of the wildcard string. If the wildcard string is a star, if the wildcard character is a star, then in that case you get dp of ij is true if dp of I minus 1 j is true or dp of I j minus 1 is true. So either you keep this star as empty. So if you keep it empty, you need to generate the j length pattern from the I minus 1 length wildcard string, or you use it to replace it with the jth character of the pattern. So if you replace it with pattern, then the remaining pattern characters are j minus 1, but again the wildcard string length remains I only, not I minus 1, because in star you can replace multiple characters, so I have not subtracted here. Now if any of these cases do not match, then dp of ij you need to mark as false. If the ith character and jth character are not matching, if the wild character is not question mark or star, then you need to make it as false. Finally, I will return dp of nm, which denotes can you generate the pattern or prefix of length m using the wild string pattern prefix of length n. And what will be the time complexity of this? It will be big O of n cross m, where n is the length of the wildcard string, wild string, and this is the length of the pattern. And what will be the auxiliary space? The auxiliary space here will also be equal to big O of n cross m, because that is the size of the dp table which I have taken. So let's submit it. Okay, so we have solved this question successfully. I hope you have understood this solution completely. Thank you.